rejoignez la French Tech.
So welcome everyone. Thanks for joining our kind of our first event. It's going to be an AI discussion. But before we jump into that event, let's do a quick overview to explain to the people that are coming for the first time who we are and what we do. We are La French Tech Raleigh. It's a branch of La French Tech, which is a French national program to support technology, startup, and talent. It's a unique movement that brings together startups, investors, policymakers, and community builders like us. Therefore, it's a great platform to network, connect, and meet professionals with the common interest. And we are here to help and connect people. We started in the beginning of last year, or end of last year, and we started with a few other members, Alexandra, Thomas, Stephanie, and I can't see that here, but just had to say a little cuckoo for them. And they are, actually, those guys are back to France, but the group is still going, and we're hoping to do some great stuff here in Raleigh. Moving forward, moving forward the next year, we are planning to do one of those events a month. It's quite ambitious, but we'll see where that takes us. And we're going to figure out different formats. But in any way, we're going to try to do something on a regular basis. And because we are very ambitious, we are going to be welcoming volunteers. So if you want to help somehow with marketing, social media content, or if you just want to help, I'm sure we can, reach out, let us know, and we're going to find a way to make you rock with us to support this good group here. Personally, one of the events I would love to do, it's a golf event. So if anyone wants to play golf and is interested to do a French Tech golf outing, just let me know, and I'm sure we can. I know there is a couple of guys that play golf here, so we can really have one small team here, one little foursome. So let me know, and then we can figure out something. But for today, we are pretty lucky because we've got two French CEO, co-founders, and of the startup. And so yes, I'm gonna pass the microphone to Jean-Georges, and Jean-Georges is going to be moderating this conversation. And your turn, Jean-Georges.
Hey, thank you, David. So good afternoon, everyone. It's a pleasure to see old faces, and to see old faces and new faces too, and good old friends. Some of them, it's been a long time, but COVID is not really helping to maintain the relationship you would like to maintain. So I will be the moderator. Don't worry, it's nothing like the debate we've seen a couple of weeks ago. Okay, I'm really super excited to have two very talented entrepreneurs. And I've known Alexandre for quite some time now, and we crossed paths virtually quite a few times, and we're coming from the same best region of France. And he's now in New York and is having he's got an excellent track record in computer vision. But I will leave him. I will leave that to him after. And we also have Fred. So Fred is now to become really a close friend of mine. We're almost neighbors. He's like we are not in the same room, but he's almost walking distance from me. Actually, I think it's walking distance. Actually, I should be walking distance to you, and not take the car to go downtown Scarborough. But anyway. It's a great pleasure to have these two entrepreneurs in AI, and they will describe what they're doing with AI. So the format is rather easy. They will have something like 5 to 10 minutes to describe what they're doing, using a few slides from 1 to 10, whatever they want to do, and and then after they go through that, we will have some Q&A, and so either you can ask a question yourself, or if you feel a little bit shy, don't you can just use a chat either publicly or privately in Zoom. So I will just get started, I think, and let's start by the alphabetic order. And Fred, the floor is yours.
Okay. Thank you, George. Do you see my screen and hear me correctly? Yes, no?
Yes, I was on mute. Yes, all fine.
Okay.
Right.
Okay, so we're good. Okay, good. So let me just give you, to set the stage, a quick update, a quick overview of what we're doing at LabVoice. And because of the topic of the day, what we're doing in terms of AI, or what we would qualify as kind of intelligence over there. With my associate and my co-founders, okay, our background is in scientific software. So we spend quite a large chunk of our careers building and selling software to the scientists. And every software they can use when it's time to prepare the experiments, run the experiment, capture the result of the experiment, because they must store it and build some knowledge out of that. So while we had quite success doing that, where we have always been kind of limited, and is the adoption in the lab. If you think about it, when people in the lab, they're always very busy. They're focusing on what they're doing. They're dealing with reagents and substances that sometimes could be a little bit dangerous. So they also need to be very focused on what they're doing. They're wearing protective equipment, gloves, when it's not more than that. And at the end of the day, there are better things to do than having a computer close by. And we try tablet, or even tablet doesn't work well. So, which is okay, but as a result of that, those labs, if you have a chance one day to visit, they're very manual. There are plenty of papers, people taking notes when they're not writing on their gloves itself. And sometimes they have to be two just to capture the critical information, so the second one can listen what the first one is doing. So in this digital modern world, not the best way to move forward. So that's why we are trying to solve this problem, and we are trying to leverage voice to that, to help them solve that. But more than voice, really all the full digital and virtual voice assistant that can help them. So we have a solution that can connect in all the assets they got in the lab, can connect to the instrument, can connect to their software, can connect to any features that would be of interest, and that interacts with the scientist just using voice. Okay, and it could be this smart speaker I'm representing there, but it could be the phone and a headset, and suddenly your mobile and can move easily through the labs, and still interacting with voice assistant to help you remember what you're supposed to do, what's the next step of the process, or capturing the information that's relevant just as you're doing it, capturing your observation or whatever makes sense. Okay. We are specifically good at doing that we know how to capture their process. That's what I'm trying to represent here. We spend some time at the beginning of the implementation to capture some of their process in a very modelized way. And so we know what is going through. We know what's the next step. We know what you're supposed to do. We can remind you next, and really play the full role of assistant. Okay. It's just the atomic question. What's the weather today? I mean, it's way more than that. We're going to guide you through all the steps and the process. So where we're doing that, really, like I was saying as an introduction, we're really helping them moving from this very manual and digitalize this paper trail and make those processes more efficient, make those processes more compliant. Okay, so that if you have to do things a certain way for a certain reason, we're going to make sure you're doing it. And in terms of safety as well, a lot we can do to help you keep your protective equipment on. And on these new days of COVID, we can help you reduce what you're supposed to touch and staying away from maintaining a kind of social distancing in the lab as well. Let's replace your second scripting colleague by your phone or a smart speaker. So, but just to give you a matrix that we're trying to capture to see how much we improve, but you know, for a scientist to go back from the lab and to his office, constantly typing it, getting the information he needs and so on, it's about 20 minutes a day for a person just to do that. So that's what we're going after. So that's just 2 minutes, 3 minutes, the high pitch about what elevation pitch of what we're doing. jumping into AI. So why are we using AI? And I would say there's multiple definitions for that. The one that probably everybody knows and is familiar with is the machine learning. So yes, we do a little bit of that, because as a matter of fact, that's the way today the voice recognition is solved. That's the way Google, Amazon, Siri are solving it. So it's really been, the way they recognize your voice is by the run of a model that's been pre-built before. So basically they took a bunch of audio file and their transcript and they build a model. So now when you're using that, they take this new audio file and based on the training set they had, they can predict what you meant, and here is the text. Okay. That works pretty well, and you may have seen that. We think that Amazon and Google are doing a great job and they keep progressing, so that's quite amazing. But the limit of this machine learning exercise, as always, is if you're close of the training set, you're going to be great. If you're far away, that's going to be not as good as it should be. So, which is mean for us and all our scientific terms, we're going to be a little bit far away from what Google and Amazon have trained their model with, which is the day-to-day activity. Okay? So that's why. So we nevertheless took the decision to stay with them, but we've just found a nice way to introduce our scientific vocabulary. So we could have built our own model, but at that stage, business justification is not enough. They invest way more than we do. We're better at leveraging what they do, but inject our scientific vocabularies. And that's what we typically do. So that's what we're doing today. The next thing we're doing, which is once we've got the transcript, we inject the vocabularies, the scientific dictionary, then we get the text. Then we spend a lot of time trying to understand this text in the context of science and what it meant and what you really want to do. So there's a little bit, that's what we call in our jargon a natural language understanding. Yes, I've got the text, but what do you mean? And what is the action you want me to perform based on that text? And that's what we're doing. So I would say this is very traditional. That's what I'm sure many people are in mind in terms of machine learning and AI. And we do a little bit of that to some extent. As I was saying, we're leveraging a lot of Google and Amazon. But I would say there's also definition of intelligence, to our opinion, and there's other way we can bring some intelligence. And what is nice, in what I was explaining, we've built a way to capture the process of our customer. So when a scientist needs to weigh something, that sounds rather simple, but actually there's a lot of side steps that goes with that and that he needs to go along. Lots of minutes, tedious, small steps. I'm going to be weighing, okay, with which instrument, which balance? Okay, is the balance being calibrated? No, wow. Okay, so let's stop that. I need to calibrate the balance. Do I even know to do that for this model? Well, maybe yes, maybe no. I need also probably to capture the ID of the vial I'm gonna weigh, because while am I weighing? And once I've got this weight, finally, where do I place it? Okay, probably into this software one that's capturing all my experiments, and probably I need to update the inventory, and so on and so on and so on. So at the end of the day, that's what we're doing when we work with them. We capture the process. So what's nice is that we start having a pretty deep and nice intelligence about all the processes for a company in its lab. Okay. So, and we can branch from one to another. You don't know how to calibrate the balance? Don't worry. We know how to do that. Let me start the workflow calibration, and I will guide you through that. So that's pretty interesting, all the knowledge we have captured from your company and from all your know-how in the lab. We use that more and more to train the new people, for example. That's what people are using it a lot now as well. Let me go through the process and I'm going to train you. And then we start even being more proactive now. You get into the lab and say, hey, LabVoice, what's for me today? Well, you were on the process X yesterday. Let's continue that. Sure, let's do that. Okay. Or we start having geolocalization also based on your phone. So you get closer to a workstation and the workstation start addressing you. Well, would you like to start weighing today? Because I see you getting close to the balance. And so there's also all this, we could qualify intelligence about what we know and what we can help you make your life just easier in the lab and really assist you as efficiently as possible. So that's also what we're working a lot on and trying as well to bring some intelligence in what we're doing today. And looping back to something more traditional, what's interesting by doing that, we start collecting very nice metrics about what's happening finally in your lab. So what used to be a very manual and paper trail, well, I can give you a pretty nice and accurate image now what's going on in your lab, how much of these processes are running, I can give you some type of average about across your scientists. Are they all running the same? Maybe not. Maybe some of these people could potentially be helped or need more training. If you look at the process in itself and all the run, are they all running the same? Or I can see some steps being definitely longer. If you're interested in optimizing a process, that's probably these steps you should focus on. Okay, so that's also some just finally producing metrics and data into the lab, getting you some insight. And that's where at the end, we want to look back into the machine learning again, that finally once we've got enough of those data and they're clean enough, let's build this model. And now I've got models. So based on the input I'm going to see, I'm going to start predicting the output. And so just based on how some of this workflow will be started, maybe I'm going to instruct you carefully. You're going in a way that may not be the best optimal, and let me guide you and now suggest you another way to do for your next step. And then that's going to be where the loop is fully done, and we can go back to machine learning and do even more. So that's it. That's just as an introduction to let you know what we're doing and what we're doing in terms of AI and what I think could be multiple definition of AI. And I'm sure we can talk longer about that.
Yeah, we can debate about the right definition of AI, but I think that this is going to be pretty sterile and maybe not as interesting for all of us here, focusing on the usages. Thank you, Fred. I think I already have some questions for you, but we'll wait for Alex to weigh in. Alex, please, the floor is yours.
Hello, everyone. Excited to meet the French Tech Raleigh Durham. I'm based in Brooklyn, New York. We have our own French Tech here, but it's all the same thing. We're all French engineers and trying to promote what we do there. So great to meet everyone. I'm gonna just show you a quick presentation of what we do. My company is called Norbert Health. Quick word of my background. I mean, I've been in what's called AI today, but it was more computer vision back then. I started in the field in 1997. So it was a different world back then. I was doing computer vision for satellite imagery, defense applications, and then from there on, I quickly started, companies actually. So I left big industry and research lab. I was originally at a research lab in France called INRIA. Started the first company there that took me to the US. We were doing image-based computer vision, image-based search in databases for law enforcement applications. So that brought me to Washington, D.C., because a lot of our customers were federal government. So that company went great. We sold it, and then I started another one after I moved to New York City. The second company was called PlaceMeter. PlaceMeter was doing large-scale pedestrian count and traffic counting in cities, understanding how the pulse of the city basically. With the data was useful for urban planning and cities themselves, but also retailers wanted to understand where to select the best site for the next store. And advertisers, for out-of-home advertising, wanted to understand how many pairs of eyeballs would look at their ads in the city. So we started that company with a French co-founder who had also been in the US for about 10 years, raised money here, a total of about 10 million. And then we sold the company to Netgear for the Arlo cameras. I don't know if you're familiar with Arlo cameras, but they're the first wire-free security camera. So, I like cameras being in computer vision. And Arlo back then liked the algorithm that we were running to do people recognition, action recognition, and things like that. So they acquired us to integrate our technology into their security cameras. And that's where I met the co-founder of my new company, Norbert. So you see Pat on the right there. He's more of a consumer electronics guy. He's the guy who ran Arlo from scratch and took it to IPO. And we started Norbert together, right? So I'm going to give you a quick download of what we do there. Norbert is a health tech company that started before the pandemic, but for a big vision, which is that health is moving to our homes, outside of the doctor's office, into our homes, office spaces and daily life. That has been accelerated dramatically by the pandemic. So this is what's happening now, right? I mean, we need to scan the health and vital signs of a lot more people, a lot more often, in a lot more places. And for that, you need a device that can do that. So that's what we're building. We're building that little device there that can do vital signs scanning without contact in a complete discrete and efficient manner. So building that device, that device has a lot of use cases, lots of applications, but we need to start somewhere, right? So this is where we're starting with return to work application. That's the line at the entrance of a building. Everybody needs to get their temperature checked before they get in, and that still has to be done manually. Even though we're in 2020, you would think that this is something that could be automated easily, but it doesn't work. You can buy devices that kind of work but will not be fully automated, or you can buy some devices that cost $40,000, like the airport grade health scanners that are more like big portals, where you need an engineer sitting by it all day long to make it work. So there's no automated solution that works. So we've built it. We've built that solution, that device. Again, it does contactless vital sign scanning. So you sit within or you stand within 12 feet of the device. It's going to scan your temperature, your cardiac activity, your respiratory activity, and all that with medical grade accuracy. It also does people recognition so that we can match the vital signs with previously measured vital signs of the same person and implement it this way. So right now, again, we're using that a lot for return to work, right? So here at New Lab, we've had a device at the entrance of the building for the past 4 months that's scanning everybody's temperature when they come in. We also have a couple that are sitting around the office space to passively detect, people who would have temperature that would start during the day, right? We're also starting to sell a lot to factories, food packing factories, notably, small businesses, schools. We have 5 devices at a public and a private school in downtown Manhattan right now. There's a lot of demand right now for pure temperature scanning to get back to business. I mean, the big picture and the next step for Norbert is definitely health in the home. So, but to get to that point, to be able to sell devices for home use cases, the health devices for home, you need to get FDA approved. And that takes a little while, right? On the other hand, for enterprise use cases, the FDA, explicitly provided guidance that you don't need FDA approval for temperature screening. So we can ship those devices now, mature the technology, because as you know, when you build AI systems, you need a lot of data. So we're shipping devices now for office spaces, small businesses, and schools, collecting a ton of data, maturing the technology, and getting ready to get FDA approved and go after home and healthcare use cases in the future. Quick demo how it works. This is an older version of a box. The new one looks like that. It's much smaller. So this is the entrance of New Lab. People just come in. The EMT is still there, but it doesn't do much now. It just sits by the device, and temperature is scanned within 2 seconds, automatically and with medical grade accuracy. So no more line. Everybody's happy. And New Lab here is at 52% occupancy versus an average of 10% in New York City right now. So we take a little bit of credit for that. This is how it works under the hood, right? I mean, it's all about when you measure temperature with a device like ours, you have a thermal camera and a visible light camera. So it's all about detecting where you want to measure temperature on the face. This is the highly vascularized areas of the face. So between the eyes here, or the temples, or the neck, or the lacrimal canal, good spots to measure temperature. So we have a piece of AI on the left that's tracking the face and the landmarks of the face, and then projecting that onto the infrared camera you see on the right, and finding the best spots to measure the temperature, and also analyzing if the temperature is stable and valid, and we can surface it or not. It works with or without a mask, profile, front view, whatever. You can be like 5 people behind, it's still gonna work. It also can detect when there's no spot where you can measure temperature, which is important, right? Some people show up with sunglasses, hat, and a scarf. We'll flash a light telling them take something off so we can measure your temperature. So we also do other things, right? We also measure heart rate and breathing rate, and this is done by using a combination of radar sensor and the camera and the infrared sensor that are in there. The radar sensor is pretty exciting. It measures the mechanical activity of the chest, right? It basically detects and creates a 3D image of any object that reflects radar waves. And human body is mostly made of water, and water reflects right away really well, so it can create an image of anyone who's within 12 feet of the device, and we'll understand movement, right? So we can detect the deep movement and slow movement of breathing, which is the blue plot in the bottom there. And the red plot on the top is the vibrations of the heart within the chest. So we can detect heart rate variability with that, and also breathing rate and breathing depth and breathing activity in general with the plot in the bottom. We also use something that's called remote PPG, which is understanding the pulse by looking at the fine differences of color on your skin when your blood gets in the vessel, the fine blushing of the skin, basically. That helps us get another measurement of heart rate and heart rate variability, so we have a really accurate measurement. Now, the most exciting thing there is that, if you think about it, we measure the mechanical activity of the heart, so when the pump contracts, right? And then we know when the blood gets to the end of the network, right, with the PPG technology. So we know we have a sort of time difference between the moment the pump contract and the liquid gets at the end of the network. This is a good proxy for blood pressure. So we can have an idea of the variability of the blood pressure for a given individual without any contact, which is pretty crazy. All right, so we started shipping devices 4 months ago, these big boxes that you saw, and then we're working on the new batch of these smaller boxes. We started selling them. You can go to norberthealth.com and buy your own right now. You'll get them somewhere in November, and you'll start paying for a monthly fee once you activate the device. So we're making 200. We already sold 130 of those. So it's going pretty quickly, and it's interesting to see that we have a bunch of different kinds of customers, like movie sets, right? This is interesting. You have a lot of people going to movie sets. They all need to be checked, and they all come at the same time. So it's a very good use case. Schools, of course, which I mentioned, construction sites, but also a bunch of large companies, who want to get their employees back to the office and provide a safe office space. And so, like New York Times is doing that, and we have some leads in Japan also, and of course some medical institutions like NYU Langone or the VA, etc. And I will stop there because I feel I've been talking a lot already. I can talk a lot about AI, vision, whatever is interesting to you guys.
Thank you so much, Alex. This was pretty impressive. I had no doubt it would be anyway. And this is really focusing on the usage of AI and not the algorithm behind or the complexity, the mathematical complexity. And that's really what we wanted to discuss and share with you today. Those innovators that are taking this complex math and put it into products. I've got a question from Denis to Fred, and so Fred, in your answer, you've got to be nice with Denis. Okay, he recently joined the private sector. Okay, so now he's got money. Before he was at NC State and he didn't get any money, but now he's in private sector. So be
that
nice
is correct. That is correct.
So the question from Denis, well, you can actually ask it, but yeah, go ahead, Denis.
Sure. So my very good talk to both of you, actually. My question was like, is the voice assistant / the output of that assistant can be linked to the ELN, so basically the electronic lab notebook from the lab or the company, because that's most companies now are really relying on this electronic version. So if you can link them, you're actually making it makes a lot of sense.
Exactly. So the answer is yes. Yeah, that's totally what we're doing. In both ways, we can read from it so that we can feed you information while you're in the lab. By the way, remind me how much quantity I was supposed to weigh or what I was supposed to mix. And we can as well write back. So while you are running your experiment, and you can just capture the data you want or the observation you want, and we write directly into the LN. Nothing to do when you're back to the office. No need to update this. What you've done.
So I have a question from Manuel to Alex. So Alex, is your device approved by the FDA now?
So Right now, the device is not yet approved by the FDA, and we're starting the FDA approval process probably in a month or 6 weeks. We already identified our partners for clinical trials, and we're going to claim to be measuring heart rate variability, breathing rate, and temperature. Within the range that the FDA tolerates for these vital signs. So we know that the device is already in that range, which is great. But the process takes a little while, right? So you need to start up a clinical trial, then submit the studies, and then it's going to take another probably 9 months to get there. Fortunately, right after COVID broke out, I mean, the FDA formulated some guidelines to follow to deploy devices in enterprises or workplaces for screening. It's called supplemental screening devices. So the idea is that if you have a FDA-approved thermometer in the environment or in the company where you're deploying your system, that can double check the load you would be raising, it's fine, right? So that's what's happening now. Our customers buy a system and they screen all the people automatically. If a high temperature shows up, they're gonna have to double check with the FDA-grade device.
But you still win a lot of time because Norbert is super fast and it can filter quite a few people.
Yeah, exactly.
So
instead of having to scan everyone, you only scan the rare people that have high temperature. And we realize that actually no one goes to the office when they feel sick, right? So it's pretty rare. I mean, in schools it's a little different, right? Kids, it's pretty common for kids to have a little bit of fever and don't notice it, and then they take it to school and they have to go back. But in office spaces, it's super rare.
So David, you had a question.
Oh, yeah. I don't know if it's going to be for Alex or Fred, but one of my questions is, so how do you test something where you don't know what's coming at you? Like, how do you test that?
So say that again. How do you test something when you don't know what to expect?
Yes, what to expect, because it's. I mean, when you test a software and you know what to expect, it's easy. Well, I mean, it's easy. It's fairly easy, but when you don't know what's coming at you, how do you figure out what's all your data set? Like, how do you test that?
Yeah, no, it's a great question because it's a classic pitfall of deep learning, right? Deep learning works pretty well when you test in the framework where you've been training it, right? But if you see new images or new kind of data that are borderline and that are not well represented in your training set, the neural networks will go mad. They'll do stupid things like completely nonlinear, right? So it's a classic difficulty when you train neural networks is make sure they behave well at the border, right, at the edge. There's I don't think there's any magic wand there to fix that. What you usually do is implement some heuristics. Try to detect when you are at the edge or the border of the your training world, and try to detect that and flag it. And then, of course, have a continuous feed of data to retrain your system. Or when you see new stuff you haven't seen before, annotate it, add it to your training database, and retrain your network and deploy it.
Fred, you want to chime in on this one?
Yeah. So that's what I was explaining in terms of language. We're using like Alex was saying, some model that been tuned not for exactly what we want. So we receiving things unexpected. So we're trying to inject what we can to the training data set. There's some model now in terms of language recognition. You can inject the dictionary upfront, even before the audio comes, without having to rebuild the model, which would be the ideal, but unfortunately takes time. And in our world, we ask a question and we expect the system to respond relatively rapidly. So we do a little bit of prevention by loading some dictionary when the model accepts that, and we do a lot of rescue after. That's where we know also what you expect. What's nice for us, it's a dialogue. I'm asking what question, you respond, next question. So we can fine tune dialogue per dialogue. So we can, in this question particularly I'm going to ask, I expect a temperature. in this one, I'm going to ask, I expect a text and even a list of values. Knowing all that, between what we can feed up front and what we can rescue after that, we tend to catch quite a lot and rescue a lot, but there's always some that goes through. And you've got the traditional, sorry, can you repeat that?
Just to bounce on what you just said, I think you're touching on something that's pretty important too in AI. The fact that it's hard to inject explicit knowledge or explicit models into a deep learning model. Yeah. Right? It's really two different things, right? When you train a neural network, you're going to train it on data. You're going to train it to behave like the brain or like whatever you're trying to model. So in vision, for example, you can recognize animals, people, pretty well if you have enough data. But then if you want to inject some knowledge that you will not have a cat underwater, for example, in a picture, it's very hard to do that. So there are models now, and I think it's a whole field, right? Is how to fuse and efficiently merge explicit models and explicit rules like that with implicit models that you train from a typical deep learning stack.
So my dear Alexandra, calling from France. So I see you've got a question.
Yeah, I've got a question. Thanks. Well, Fred, I'm already a fan, so I don't have too many questions. But Alex, I'm really interested about your device, but actually I'm more of a HR person. So I'm actually super interested of what such a device could bring from a work health and safety point of view. So I'm a bit curious about beyond COVID, which kind of, work health issues or workplace related disease would you look to prevent? Because immediately I was thinking, well, hang on, this would be amazing to measure stress level in an organization. And actually with machine learning, I can just imagine myself thinking, okay, all interactions of bullying could be identified by heartbeat and stuff like that. And the machine could learn because you can see the heart rate, rising and things like that. So I don't know, from a HR perspective, I just find this fascinating. So I'm very curious about the work health and safety possible applications.
Yeah, no, it's a great question. Definitely some use cases we're looking at for a little later in the future. But yeah, I mean, stress can be efficiently measured by breathing rate and heart rate variability. These are two measures we have. This is a really good indicator of that. The question is, these devices have a range of about 12 feet, so you can put them like in the close to the coffee machine or in a conference room or common areas, and then you can occasionally detect the vital signs of people. It's hard to have a complete coverage of an office space with devices like that, right? It's more like a spot measurement. So they're much better at understanding trends over time, right? Because these devices recognize people, so we'll know it's the same person that we measured. And last week their HRV was that level and it's going up. It's not good, right? Or their breathing is changing, right? It's changing pattern. That's not good. That something's changed. So they're much better at identifying, trends over days or weeks than identifying a specific event like somebody just gets stressed right away or But yeah, I'd be interested in talking more about that because these are use cases I'd love to get into. We're collecting more and more data. We already have 170,000 data points. So data points meaning that one person, we have all their vital signs. They're mostly here at ULab, so it's mostly the same people. So we already have some, capability of detecting these trends. And so I'd love to, talk to HR specialists or chief happiness officers to see how you could leverage that kind of data.
Thanks, Alex. That was a great answer. I've got a question from Liping. Liping is a close friend of mine at work, and she's asking me to answer questions for her. So she said, "Thanks for sharing the cool work," and that's not for you, Fred. That's for Alex because your work is not cool. She didn't say that, but I'm assuming. You mentioned the facial image you will be stored during the vital signs scanning. Would this image be used for future reference? How long are this image stored? stored, or are they used for any other case?
So we don't store the actual image. We store the weight of the neural network that's used to recognize the face. So we don't store any human readable data unless you want it, right? In some cases, like we work with a food packing industry, right? And so there's a lot of workers who are, not high wages, and there's a lot of turnover. And if there's a problem, they need to be able to track and find the person. So these guys want to store the images. Here at NewLab, we keep the images for 20 seconds and then we remove them, just to make sure that the person who came in was scanned and then it gets removed. If we detect a potential problem, like high temperature or heavy coughing, then we'll store the image as well. That's the only case, and it's all configurable. But privacy, of course, is super important, in these topics, and it really varies on states. Here in New York State, we have pretty stringent privacy rules, so we're not allowed to store anything. The other states are more flexible. It also depends on the kind of industry and the kind of organization you're in. Are you scanning employees? Are you scanning members of a gym? Are you scanning children in the school? There's many different rules, so we make sure that our system adapts to that.
Yeah. As a matter of fact, we've got the same problem because the voice has been considered personal data as well. So we're getting challenged the same. Yeah. What are you doing with the voice? What are you capturing?
There's one great thing about AI and your networks is you can really separate the different layers of a network, right? The first layers are typically sensory layers. So you train in them a lot of data, a lot of images, and they'll be pretty generic. And then the higher layers of network will be more semantic layers. And you can retrain those layers to implement face recognition versus object recognition versus people recognition for different things, right? You can use these the weight that come out of these lower layers, which are not human readable at all, and you cannot reconstruct an image from them. And then you can use that for many different applications in a very private manner, right? It's a little bit like what federated learning does, right? So training and getting weights from lots of devices on the edge. That's what Apple does, and then using that in the central system to retrain big neural networks based on all that data that anonymize and then.
The next question is from Vaskok. Are you concerned about any ethical or privacy issues that will be undoubtedly run into promoting wide adopting of this technology? I think that's valid for both of you. And it kind of, I'd like to add, is there any legal implication to that? Maybe Fred, you can start.
Yeah, but like Alex said, we've got a way to go around that. Okay, we don't specifically need to capture the input data and the voice, in my example, or show the image for Alex. We use it at a given instant. Okay, we're more interested in the outcome that comes out of the model and then run with that and execute what you're dealing with. So we have ways to do that. It was interesting. It has been a business decision for us at the beginning. There was an option that could have been to go just with Alexa and Google Home and just develop skill and develop that through skills. But then we were depending of Amazon and Google, and then the privacy would have been probably too much. We had no way to guarantee to a customer that nobody would do anything with the voice that's getting recorded. So that's why we have got our own hardware for that. But as long as so we can now convince and we can support and handle any audit that our customer is interesting to go through. So there's no issue about that. So I don't think it's gonna be an issue for us. The only issue which is interesting on the other way, we're dealing with two types of labs. The research labs is all about IP, sensitive data. So that's where we need to be careful that we're not capturing anything. But there's another beast of lab, which are the development labs, the clinical labs, the regulated labs at the very end of the front. And on those guys, we absolutely must do the opposite, is to keep the voice and present the text at the same time we present the voice. It's considered raw data. They must be stored. They must be captured, validated. So we actually had to build a system with the two options.
Alex, any comment on that part?
Yeah, I mean, I think I kind of covered it a little before, right? And it's you have to be flexible based on the use cases, and there are cases where it's really about monitoring people and tracing back, especially now in in this COVID time, right? It's all like what happened in 2001, right? There's sometimes where you just you have some imperatives and you have to be a little more flexible. Is it for good or for bad? I'm not I'm not taking any position on that. It's just that the world is like that today. I think we've been always super careful to make sure that privacy is built in, and everything we compute is encrypted right away before it hits the drive, and only our users have the ability to decrypt the data. But yeah, there sure is that question around privacy has become a lot more complicated with neural networks because you have different layers of data. You have to understand them precisely, right? Already I was telling you that you can't reconstruct an image from weight you get from neural network. That's not really true, right? You can always do something. You can always infer something. It's not going to be exactly the same image. It's going to be a statistically accurate image, but you can get some information, right? There's also some interesting derivatives, right? My last company was doing traffic counting, and we were not allowed to report any localized counts of people that were less than 10 people, right? Because if you cross that information with another information, let's say cell tower information, one person was in the vicinity, like a 1 light radius, and then my device said, okay, there was one person at that time, then you can identify that person, right? So, complicated topic.
So I got a question in the meantime for me. Yes, this meeting is recorded, and we will share that, and I will send that and share it on LinkedIn and through the traditional media. Yeah, and so a quick one for Alexandre, but you may not have to answer. What kind of neural networks are you using for Norbert?
Well, lots of different ones.
Pick one.
Yeah, we have a ResNet architecture for face recognition. We have much smaller networks for infrared processing, more like MobileNet inspired networks, because it's low resolution data, right? Neural networks don't like low resolution, so I'm still not clear why, but they don't like it. So it's a little more complicated to train. We also use other kind of machine learning models, right? We still use AdaBoost cascades. We use we use random forest algorithm to track the landmarks of the face. And the big challenge, and where we have to be creative and really play with neural networks that are not very common, is when we do data fusion, right? When you want to merge information between the radar and the video and the infrared sensor, then you need to be creative. And that's where I can't talk about.
So we're kind of almost running out of time, and so we've got, I would say, two last questions. One are I'll get this one, and Denis, you can ask yours after. And Stephanie after. Okay, and then we'll probably wrap up. My question is, what are the challenges you are facing when you're selling to the enterprises? Okay, I was running a startup in France, and they all said, "Oh, well, you're innovating. That's awesome. You've got a great product there. Can you show me your references?" So what are you facing? Now, maybe we can start by Fred. What's the challenges? What are they teasing you with?
Well, I think in my situation, the challenges are much more as it's a new, we're trying to disrupt this lab that had been functioning like that for decades, and they were very happy with their paper. So that's interesting. So it's just change management probably for us. It's also new technology. Okay, so like new technology, you need to demonstrate the value first because you're gonna get the we used to do differently and what's in it for me. So we go. So that's mostly what we're doing. I did the same thing for cloud. I spent a lot of time evangelizing this industry with cloud as well before. So I think I know to get there, to get around them. I know them well enough. And we've got plenty of tricks. We're doing early adoption program, free trial, all that. You need to demonstrate the value first, and then you grow from there.
Alex?
I mean, I think the biggest challenge when it's of the enterprise is finding sales guys that are good. Salespeople. That's always a big challenge. I mean, it makes a whole difference, right? If you have a good sales team versus an average sales team, you can be impact of a factor 3 or 4 on your revenue. So right now, me and my partner are doing the sales, but we're looking for a chief revenue officer or COO to run both sales and or sales operations. Super hard to find. Even harder than machine learning engineers now.
So, Denis, you had a question, and it seems pretty technical, so I'll let you please ask your question. But you've got to unmute first.
Yes, thanks. Thanks, Jean-Georges. Yeah, quick technical question. It was for Alex. So this kind of high throughput temperature screening technology, can you use that for something else than humans? Like, can you do that eventually if you retrain your neural nets, etc., for like, for example, animals? If you had like 500 cows in one stuff and you want to detect the 2 cows that have high temperature, for example.
Yeah. You could do that. I mean, it's not an immediate market right now, but yeah, in theory, it's applicable. We've had the same question from a Japanese partner who was more interested in pets at home.
Sure.
We're not doing it right now, but yeah, at some point we might do that.
Okay. Cool. Thanks.
Stephanie?
Yeah. Hi guys. It's great to hear from Norbert Health. I didn't know your product. It's great. But I have a question for Fred. You mentioned the transcript that you got from Amazon and Google. What is the business model behind it? Is it open source? Is it something that you buy, and how is it maintained?
It's a pay-per usage model on their side, which is pretty cheap. Okay, per transcript. So we just refactor that and recharge that back to our customer. So the
and is it something? Okay, and that's a model which is pretty common for AI, or is that something very specific to your company?
For AI, I wouldn't know. For my industry, it's pretty common, and then we are applying that as a SaaS typical pricing. That's our business model. We're selling subscription to our service. Now for AI per se, I don't know if that I don't know. Do you charge per, Alex? For example, do you charge per screen or per device? I suspect.
No, we charge per device per month. When you buy the device, we sell it at cost basically, and then the monthly fee is almost 100% margin because all the processing happens on the device.
Yeah.
Okay. Sorry to finish on a financial question.
No, you're right. It's an interesting question. Because on one stage we're paying, exactly. On one stage we're paying, and we're gonna have this bill that we know, and then we charge a monthly fee. So we have to make sure that the monthly fee, even if the guy is very chatty, is gonna cover my bill from these guys.
Absolutely. Great.
Thanks, Stephanie. Yeah, thank you. Thanks, Stephanie. I think it's better to finish with a financial questions rather than a legal questions. Okay. Sorry, Derek. Anyway, so I think we kind of wrapped up. I want to keep us on time. I've got an important meeting at 1 as myself. I think this was
more important this one.
Of course, more important than this one. I just wanted to thank you very much, Fred and Alex. Alex, I really appreciated the name of your machine. I think Denis may get the code word, but Vedele as a machine, that's really a good one. For the people outside of that, they'll have to look on Google what a Vedele is. Thank you, guys. See you next month. Next month, we are going to have an event on AI and education. So we will have speakers from Schema and I think someone from Duke as well, and talking to us about education in AI, educating AI. So it's all this kind of mingled things there. So and look out for the recording of that. We will share. And well, guys, have a wonderful afternoon for the one in the US, and a wonderful evening for the ones in France. Bye bye.
Thank you.